We just saw some examples where we had to repeat integration by parts. Well, sometimes you have to repeat it lots of times, and oh wow, that takes up just a lot of time. So the good news is there's actually a shortcut called the tabular method. The bad news is that it doesn't always work for everything. It does work if the one part can be derived down to zero, meaning it's an algebraic expression and you can just keep taking the derivative until you get down to zero. And if you have that, the other part also follows one of your basic integral techniques. So very useful for powers of x multiplied by e's, sines, and cosines. Let's see how that works. We're going to set up a table. And just like we've been labeling my process, I have u and I have dv. So still using that same mnemonic, I have x's and I have e's, so x's are going to be my u because that's my algebraic expression, and my dv is going to be the other part. Alright, so on the u, I'm just going to keep taking the derivative. So if you had notebook paper, you'd have like these little lines, right, of notebook paper. So let's see what happens. Take the derivative of x cubed. Yes, you get 3x squared. Take the derivative, take the derivative, take the derivative. And that's what I mean by taking the derivative until you get to 0. Now, on the other side, of course, we have to integrate. So you've got to be really careful when we're integrating e to the 3x, not the derivative, but the integral. You're going to get 1/3 e to the 3x, 1/9, 1/27, and 1/81. Okay, we just have to divide by 3 every time. Now remember, on the integration by parts, there's that minus sign, so we have to take that into consideration. So your first line is going to be positive, remember, u times v. Then the second line negative, positive, negative, positive, just alternates. Then what's going to happen is you're going to multiply. Remember, u times v, you're going to multiply those. Going to go on the diagonal. And of course, u, the 0 times anything would be 0, so we don't need that. And believe it or not, we are ready to write our answer. So if we have the integral of x cubed e to the 3x dx, it's going to equal to 1/3 x cubed e to the 3x. Then I'm going to have minus 3x squared times 1/9. So that minus 3 1/9, that's going to be minus 1/3 x squared e to the 3x. Then the next one, I have positive 6/27. 6/27. You could leave it as 6/27. I'm going to actually reduce that to 2/9, and that's going to be x e to the 3x. Then my next one, let's see, I've used the positive 6x. Now I have negative 6 times 1/81. And again, you could write that as negative 6/81. Or you could reduce it down to, it is going to be negative 2/27 e to the 3x. And then, of course, you put plus c. Now you can try that problem again and write it out the long way, but you're going to end up in the same spot. So much easier when you can use it. So let's look at another problem. Okay, so first of all, I'm going to look and say, could I use the tabular method? Remember, it doesn't always work. Really good for powers of x multiplied by e's, sines, and cosines. So that's what I have. So again, I'm going to set up my table. So I have u and I have dv. So your u is going to be your algebraic expression. Your dv is going to be the other part. Okay. On your u side, you want to just keep deriving until you get down to 0. And it's really helpful if you have lines on your paper so you can kind of match them up. Okay, so we need to be careful. How do you integrate cosine? It's going to be the sine of the same angle, but you have to compensate for the 2, so that's going to be 1/2. Then how do you integrate sine? That's the negative cosine, but again, another 1/2, so that's going to be a 1/4. And then keep going, so we're going to have the positive sine, and we're going to have 1/2, but that's going to be negative 1/8. One more time, so we're going to have positive. Actually, the integral of sine is negative cosine, so a negative and a negative, that's going to end up being positive 1/16. Okay, so we start out with plus, minus, plus, minus, plus, multiply, 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 and be done. Okay, so we have this problem equals these multiplied together, x cubed over 2 times the sine of 2x. These multiplied together, so that's minus 3/4 x squared. These multiplied together, I'm just going to come to here, is minus 6 over 8 times the sine of 2x. And we should write that as negative 3/4. And then this minus times that, that's going to be minus 6/16 times the cosine of 2x plus that c. So again, it'd be nice if you went back and reduced those fractions, but not that big of a deal. I am just going to go ahead and rewrite this. And I still really can't fit it on one line. So tabular method, really a time saver. But can you use the tabular method for this problem? We've got x to the 5th. I can keep taking the derivative and get down to 0. But remember, the other part of the condition is that the second part is something that you can easily take the integral of. Well, we can take the integral of that, but it's like x minus a natural log of something. It gets messy. So the tabular method would not be good for this problem. So far we've looked at several examples of your standard integration by parts. We looked at one where we had to repeat it just one time. That wasn't too bad. But you have some problems that you have to repeat a bunch of times, and the tabular method is nice, but doesn't always work. Now we're going to look at problems like this. E times cosines, E's times sines. And let's see what happens. I believe sometimes we're going to feel like that we're going to go around in circles. But we're going to get there. Okay, so going back to our mnemonic, in this problem, what should we let u equal to? The e or the cosine? Well, this mnemonic suggests that we should let u equal to the trig function. But I'll be honest, you could choose either one and we're going to end up with the same answer. But I'm going to be consistent. So inverse trig functions, logarithms, algebraic, t trig before e's. Okay, so I'm going to let u equal to my cosine of 2x, and I'm going to let dv equal to everything else. Okay, so taking the derivative, and this is where you kind of cannot get confused between are you taking the derivative or the integral. This should be negative 2 times the sine of 2x, and the integral here is 1/4 e to the 4x. All right, so we have, here's our problem. So equal to u times v minus v du. And again, a minus and a minus, and I have a plus 2 over 4. That's going to be 1/2. And then I'm going to have e to the 4x times the sine of 2x dx. I'm looking at this integral. Sure looks a lot like that problem. So guess what? I need to do integration by parts again. And remember, the tabular method would not help us here. I can't get down to 0. All right, so let's do another substitution. So this time, I want to be consistent. So I'm going to let u equal to my trig function, and I'm going to let dv equal to the other part. That's 4. So I take the derivative of your sine, which would be positive 2 cosine 2x dx, and integrating this again, okay, so I have this problem, bring this down, and I'm also going to bring down this constant, and I'm going to put a big bracket, okay, so I can remember that when I integrate this, I'm going to have to distribute that 1/2. All right, so let's go. We have u times v again, so that's going to be 1/4 e to the 4x sine of 2x minus that integral. So v du, so I have the 1/4 and the 2 again, so that's going to be 1/2. And then I have e to the 4x cosine 2x dx. Well, doesn't that look familiar? That's the problem. Do you feel like you just went around in circles? I do. But we haven't done anything wrong. We actually can solve this. Just let's clean this up with all those constants and stuff. First of all, I want you to recognize that these are exactly the same. So I'm going to let the letter I stand for that integral. Okay, or you could just write it as that integral, but I'm going to write it as I, meaning the integral of e to the 4x cosine 2x. So I'm going to bring this down, so I have 1/4 e to the 4x cosine 2x. I'm going to distribute. Going to distribute here, so that's minus 1/4. And what did I just call that? I let that be I. Or in other words, you could say P for problem, or not even use a variable, but that's what I'm going to use. I want you to see that we're actually solving an equation for I. So just back like in baby algebra, we can add 1/4 I to both sides. Okay, solving for I. Now remember, this is 1 plus 1/4. So that's 4/4 plus 1/4. That would be 5/4 I equals to all of this. Okay, remember I was my problem, so how am I going to get I by itself? Again, back to algebra. I would just multiply both sides by that reciprocal. So I have I. I'm going to go back to what was I equal to? The problem. Okay, so now I'm going to distribute. So I have 1/5 plus, let's see, 4, 8, that's going to be 1/10. And since I'm integrating, I have to remember to put that constant. So that is repeated, and you end up with the same thing, and you have to collect like terms, and you just need to be very careful.